Good morning. This recording is for Pre-Algebra Chapter 7, Lesson 1, Solving Two-Step Equations. To solve a two-step equation, first undo addition and subtraction, which is low priority operations, then undo multiplication and division, which are high priority operations. After that is exponents and parentheses, etc., but we're not there yet. All right, so really you're only going to be undoing addition, subtraction, and multiplication and division today. All right, so what do I mean by undo? To undo, perform the opposite operation to both sides of the equal sign. All right, both sides. It's very important that it's both sides. Also, very similar to one-step equations, which you should all be very familiar with. Okay, so here's a one-step equation just to make you remember what you've done previously. T plus 9 equals 14. So how do I undo what's happening to t? Well, what is happening to t? It's being added to 9, or 9 is being added to it. So the opposite of adding 9 is subtracting 9, and I'm going to do it on both sides of the equal sign. As you guys can see, I'm making this little orange table here so that I can make sure that I do things on both sides of the equal sign. And as you can see, the little t comes down right underneath the equal sign, which means if I do it on the left side of the t, I have to do it on the right side of the t, and vice versa. So the plus 9 and negative 9 cancel out, gives me t equals 6. Now, if I were to plug 6 back into t, I would not get the correct answer because I didn't add correctly. There we go. There we go. I technically didn't subtract correctly. 14 minus 9 is 5. There we go. All right, moving on. Probably like, Miss DH, what the heck? Is it too early? Yes, it's too early. Okay, so 2 is a two-step equation. We have addition going on and multiplication. Remember that when you have a number right next to a variable, or right next to a letter, it implies multiplication. You just need to know it's being multiplied, all right? So we need to take care of, well, I'm going to make my table and see how the t comes right down by the equal sign. I need to take care of what's happening to x. It's being multiplied by 15 and it's being added to 3. But I take care of low priority things first, which means that if I'm going to undo something, I need to undo addition and subtraction first. Okay? So I'm going to subtract 3 on both sides because it's the opposite of what's going on. If it's being added, if 3 is being added, then I need to subtract 3 on both sides. Okay? So that's going to cancel out, leaving me just 15x, Miss DH. Wow, I was tired when I made this. Okay, let's fix that. This is 15x. There we go, which means my next answer is going to be a little off. So let's see what I did. All right, so 15x is equal to 45. Well, that still works because 48 minus 3 is 45. But now we need to divide. And unfortunately, I divided by 5 instead of 15. All right, because 15 is being multiplied by x. So the opposite of multiplying 15 is dividing 15, which I do need to do on both sides now that it's there. Okay, so now if I'm going to do this, I'm going to divide 15x by 15, which is the same as 15x divided by 15. There you go. Because remember, I thought it was a 5, but it's not. It's a 15. Well, 15x divided by 15 is just x. Okay, so now on the left side of my equal sign, I only have an x left over. All right, and now I need to divide 45 by 15, which is not 9, because that was back when I thought 15 was 5. So 45 divided by 15 should be 3, which it is. There we go. So now if I'd actually done what I told you to do, which is to check your answer by plugging what the variable is into the equation, you would figure out that you got the wrong answer because, well, I'd figure out that I got the wrong answer. But let's go ahead and check this one. And I'm just going to do it on the side real quick. So we have 15 times x, which we thought was 3, plus 3 equals 45, or excuse me, 48. 48, there we go, that's an 8. All right, so what's 15 times 3? Well, 15 times 3 is 45. 45 plus 3 is 48. Well, yep, it is. So that means that x really is 3. Okay, because I went through and I checked it. Since this works out, and it must be the correct answer. Okay, moving on. So, third question. It's still a two-step, because that's what we're working on today. What's happening to t? We have t divided by 4 minus 10 equals negative 6. I'm going to make my little table, and I'm going to go ahead and get started. So, I need to take care of low priority things first. That means that I need to add 10 on both sides first, because adding 10 undoes that minus 10. I'm going to add 10. That's going to cancel out. Minus 10 plus 10 cancels out. That's why we do the opposite. Opposites annihilate each other. If you've learned anything about matter and antimatter, you know that if they are matter and antimatter are in the same space, they annihilate each other. Well, it's the same thing in math. The opposite operation annihilates itself. So if you've got minus 10 and you have positive 10, they annihilate each other. Gone, right? Well, they're gone on that side. The only thing is we got to keep things balanced. So what I do on one side, I have to do on the other. Hence why negative 6 is now being added with 10. So negative 6 plus 10 is 4. And I still have the t divided by 4 on the left side. So how do I undo divide by 4? Well, the opposite of division is multiplication. So I'm going to multiply by 4 on both sides. A multiply by 4 and a divide by 4 annihilate each other, leaving me just t, and t equals 4 times 4, which is 16. And again, you can check it out. 16 divided by 4, if I were to plug it in right there, 16 divided by 4 is 4. 4 minus 10 is negative 6. So there you go. I did check it this time, and I actually got the right answer. Unlike that second problem, to the second problem. All right, moving on. So, 7 minus x is the same as 7 plus negative x, and that is the add the opposite, guys. Remember this? If I go add the opposite, wherever I have a subtraction sign, I can turn it into an addition sign and take the opposite of the second number. Opposite, right? Good. Okay, so yeah, let's go ahead and do this. So we have next problem is negative a plus 6 equals 8. So, what is happening to the variable? Well, what? Well, we're going to undo it by doing the opposite on both sides of the equal sign. That play button was supposed to keep going all the way through that, and it didn't. Anyway. All right, so what's the opposite of adding 6? Now you can be like, Miss DH, what about that negative? Well, that negative on the a is actually being multiplied by a, because you can actually write negative a as negative 1 times a. All right? And that's why we don't take care of the negative first. We're actually going to take care of any addition and subtraction first, and then take care of any negative signs that might be attached to the variable, to the letter. So, let's take care of that 6 first. The opposite of adding 6 would be negative 6. Wow, that play button is like taking forever. All right, so we're going to minus 6 on both sides. The plus 6 and the negative 6 on the left are going to annihilate each other. Bam. And we're left with negative a is equal to 2, because 8 minus 6 is 2. All right, so now let's go ahead and take care of that negative 8. And again, remember, I can write negative 8 as negative 1 times 8. All right, it's the same thing, or times a, not 8, times a. So a is being multiplied by negative 1, which means the opposite of that would be to divide by negative 1. But what I do on one side, I have to do to the other. So I'm going to end up with, oh, and by the way, the negative 1 times divided by negative 1, they annihilate each other because they're opposites, right? So a is equal to negative 2, because 2 divided by negative 1 is negative 2. All right, and you can go and check your work. If you have the opposite, negative a plus 6 equals 8. And remember, whenever you replace a letter with a number, you put the whole number inside of parentheses. And that will become important later. So the opposite of negative 2 is positive 2 plus 6 equals 8. Beautiful. All right. And test it. Oh, and I just did. Oh, check out all that extra work I just did. Oh, bummer. But you got it, right? We're going to test it. When we tested it, and we tested it good. All right. So it ends up working, so we're good. All right, next problem. -9 minus y over 7 equals -12. Okay, so I'm going to go through and add the opposite. You should probably do this every time. All right, so see how that subtraction sign becomes an add the opposite, and it's always the next term, the second term that gets the negative, all right? Don't forget it, all right? Adding the opposite means that you're going to add the opposite of the second number. All right, so add the opposite every time, or first every time, and it saves confusion later. Just trust Miss DH on this. Do it now so you don't have to worry about it later. Okay, so let's go ahead and try getting y by itself. We're going to take care of low priority things first, which means adding and subtracting. Now here's the confusing thing. You'll be like, well, Miss DH, we're dividing by 7, I got that, but now we're adding a -9? Well, if you've got a negative, you actually just want to do the opposite of that. So if it's -9, you really want to add 9 to annihilate it, okay? It's the opposite of it. So even if you have -9, it's going to be adding 9 on both sides. Okay, pay attention to that. That one's a tricky one, and a lot of people get stuck up on this one. So make sure you do the opposite of what's going on. So you'd be like, well, I need to subtract -9. Well, if you subtract -9, what's the opposite of -9? Well, that would be +9. So you're still adding 9, even if you did this whole crazy other thing, okay? So just do the opposite, and you're going to be fine, all right? So we still have -y over 7 equals -3, because -12 plus 9 is -3, right? Right. So now here's the thing. We added the opposite to that y over 7. The thing is that I could technically put this negative on the 7. It doesn't matter where it goes, because remember what I said that earlier? So like if I have -1/2, it's the same as -1 over 2 or 1 over -2. They all mean the same thing. It means that I can put the negative either on the y or on the 7, and it's going to not matter, okay? So if I put it on the 7 and then move a -7 on both sides, I'm going to cancel out the negative so that I actually don't have to do what I did over here. Okay, I don't have to do that if I put the negative on the 7 instead of the y. Okay, so again, multiplying by -7 and dividing by -7 annihilate each other. And I'm going to end up with y equals +21, because a negative times a negative is a positive. And if you plug it back in, it's going to work using PEMDAS. So if I plug it back in, even to the original problem or the one I already added the opposite to, it's going to work. Okay, so go back and try it. Now, if it doesn't work, that means you did something wrong. So it's always good to check, because then you know actually if you did your work right or wrong without even having me grade your assignment or you grading your assignment. You can just check. And it's a little extra work, but hey, a calculator can do it pretty fast and you can check your work. All right, last problem have to do with begonias. Those are begonias, by the way. If you can't visualize what begonias are, those are begonias. Okay. Jacob bought 4 begonias in 6-inch pots and a $19 fern at a fundraiser. He spent a total of $63. Write and solve an equation for the price of the begonias, where P is the price. So, we have 4 begonias, but we don't know how much they cost. We have 1 fern that cost us $19, and the whole smash cost us $63. So, we need to figure out the price of the begonias, which is going to be P. All right? So if we say that we bought 4 begonias at the price of P, we're going to say that 4 is times P. 4 times P, which is the money we spent on begonias. And then we're going to add what we spent on the ferns, which is $19, and that's going to give us how much we spent in total, which is $63. All right? There we go. There we go. All right. So let's go ahead and solve for P. Our original equation was 4p plus 19 equals 63. We're going to subtract 19 on both sides, which annihilates those 19s on the left. We're going to get 4p equals 44 because 63 minus 19 is 44. We're going to divide by 4 on both sides, and we're going to, the 4 multiply by 4 and the divide by 4 annihilate each other, and we're going to get p is equal to 11. So guess what? The begonias cost $11 each. All right, I'm done. Bye, guys.